Good day, Extension students. So today we are going to take a look at the notes for Extension Lesson 5-1, Graphing Proportional Relationships. So if you recall back from Unit 5, depending on when you're looking at this, for something to be proportional, we know that proportional, or a constant of proportionality, it has to have that constant unit rate. Right, those were those problems where we checked all the values in the table and we did those unit rates to make sure that they were all the same. So we're not going to be doing that here because we're going to know that these relationships are proportional. So we know that they already have a constant unit rate, and that's not something we need to be checking for. You also might remember that the graph of a proportional relationship has to have two requirements. Actually, let's go the other way with this. A graph of a proportional relationship has two requirements. And maybe you remember those requirements as one, the first one, it must be straight. If it's not straight, if it has any types of curves in it, it's not going to be proportional and is no bueno. And the second requirement, if you remember, it has to be straight and it must pass through or touch that origin point, which that origin was 0, 0. Excuse me. Okay, so then furthermore, goodness. That's not necessary, honey. My dog's barking at people. So the equation of a proportional relationship, which you just did a question on your take-home quiz like that, is that y equals kx. And remember, the only piece we're filling in is k. We only fill in that k. And if you recall, k is your constant of proportionality. Proportionality, aka that constant unit rate. So the only thing different in this extension lesson is that instead of answering questions about the equation or making the equation, you're going to be graphing the equation. So when you're graphing this, there are a few requirements or a few things that you need to make sure you're doing so you're getting full credit. The first requirement is that you're going to need to use a straight edge. Rather that's your cell phone, the side of your phone, a actual ruler, or maybe the edge of a book, depending on where you are and what you have available to you. But your lines need to be straight. You will lose points if you try to draw me a curvy line. So use a straight edge, aka a ruler. Your second requirement is you need to take up the entire grid. I'm going to show you how we're going to plot points on these grids, and you're going to want to take up the entire grid. I don't want to just see, 2 points with an itty bitty baby line like that. That is not taking up the entire grid and doesn't look very nice. And the last requirement is that we know that lines are infinite. They go on in both directions forever. So when you're graphing these lines, you need to have arrows at both ends. Okay. Alrighty. So when we're graphing, we're going to be looking at that k value, or that constant of proportionality. And that k value is going to tell us how to move on the graph. So when you're graphing, you are always going to start at that origin point. So we're always going to start at that 0, 0 point. That's the first point we're always going to plot on our grid. Then we're going to use the k value to move. And how we're going to use that k value to move, we want that k value to be written as a fraction. And when we look at the fraction, the top or the numerator is going to tell me how much to rise by or go up or down technically. And the bottom is going to tell me how much to run or how much to go left or right by. And we will take a look at these in our examples. And I'm just going to keep going right through all in one video here. So if you need a break or need to pause it, please feel free. Okay, so looking at example number 1 here, I have your average y equals 6x telling me that that k value, and I'm going to go off to the side here, that k value, just kidding, guess we're not going to write anymore. The k value is 6. Now, we want that to be as a fraction, so I can very easily turn that whole number of 6 into a fraction by putting 6 over 1. So that tells me I'm going to be moving up or down 6. Well, technically, we're just going to be going up 6 because it's positive. And then if I have a positive 1 on the bottom, positive would be going to the right. And that's just coming from that rise over run. All right, so here we go. Starting at 0, 0. That's the first point I'm plotting. So now my slope is telling me to go up 6. So I'm going to go, So I'm going to move up 1, 2, 3, 4, 5, 6. Not putting my point there yet because I'm not done. Jesus. Cheese and rice. 1, 2, 3, 4, 5, 6. So not moving, not putting the point there yet because I haven't moved right at all. I need to go up 6 and then right 1 before I can plot my next point. And so now you might be thinking, I can't fit another point going upwards. That's very true. But now I can go backwards so I can take up the rest of my grid here. So instead of going up 6 this time, I'm going to do the opposite of that. The opposite of up 6 would be down 6. 2, 3, 4, 5, 6. And instead of going to the right one, I'm going to go the opposite, which would be left one. And there is my second point I can plot. I can't fit anything else on there, so I can just go ahead and make my line. Again, you're going to be using a ruler. I actually have tools I can use as well. Boom. Mine's not as nice as yours, but let's see if I can make this work. Feel free to fast forward past this part because that's kind of ridiculous. So not the best line because it's not exactly on it. Let me see if I can just try and freehand it. You would be using a ruler at this point to connect those points. And there is your equation of y equals 6x. Notice I've got my arrows at both ends. I took up that entire grid, used a ruler. And yeah, that's it. That's all. Okay, moving onward. Example number 2. So here in this one, you can see that we have a different k value and we don't have y and x. That's okay. I can rewrite this as y equals 5 over 4x. It's okay to use different variables. We'll know that the k value is always next to the x. K, the constant of proportionality, is next to your x, or whatever your x variable is. All right, so my k value is equal to 5/4. And remember, we're looking at that rise over run. Rise over run. So that tells me, because it's a positive 5, that tells me I'm going to be going up 5 and right 4, because that's the positive way. Again, starting at my 0, 0 point, my origin, and then going up 1, 2, 3, 4, 5, right, 1, 2, 3, 4. And there's my next point. And if you had room, you could just keep going up 1, 2, 3, 4, 5, and then to the right 4. Okay, so same process here. I'm going to go backwards now. And you would know if you were going the wrong way, because if I went, the opposite of up 5 is down 5, 1, 2, 3, 4, 5. And let's say I accidentally went right 4 again. Right there, I know that that cannot be correct, because if I were to connect those points, I would not have a straight line. That is not a straight line. That's a V. It turns around and goes back. Not a straight line. Red flag. So not just going down 5 this time, 1, 2, 3, 4, 5, but then the opposite of right 4 would be left, 1, 2, 3, 4. And there we have our second line. Again, you're using a ruler and making that look perfect, because perfection is... Okay, example 3, a little bit different, but just same kind of process here. So they give you this situation. They want you to first write an equation and then use your equation to graph. So at the local store, 5 boxes of candy cost $20. So remembering old school unit 5, we need to find a unit rate first. So thinking about setting up a fraction division to find our unit rate, do we want to know how many dollars per box or how many boxes I can get with $1? Dollars per box is the way we want to go on that. So I'm just going to check that 20 divided by 5, which I know is 4, and 12 divided 3, which I know is 4. So it seems to be that $4 per box is my constant of proportionality, or my constant unit rate. Using that equation, that y equals kx equation, I'm filling in that k value, just like we've been practicing. We found our k value to be that $4 per box. So that gives us our equation of y equals 4x. So y equals 4x. Okay, graphing it just like normal, starting at that 0, 0 point. Here, my constant of proportionality, my 4, isn't a fraction, but I could very easily turn it into a fraction by putting it over 1. Again, that slope is that rise, or not the slope, the constant of proportionality, that constant unit rate, that k value is your rise over your run. So I'm going up 4 and right 1. So up 1, 2, 3, 4, right 1. Ooh, I actually have room to do another one here. So I'm going to just keep going. Up 1, 2, 3, 4, right 1. And then I will go backwards. Instead of going up 4, I'm going to go down 1, 2, 3, 4. And instead of right, I'm going to go left 1. 1, 2, 3, 4. The more you count it out in your head, the less likely you are to make counting mistakes. Swoop, swoop, swoop. So as you can see, all of these are straight lines and are going through the origin, just like we know a proportional relationship has to. All right, example 4 being a little bit different than the previous ones, simply because we have a negative sign here. So that is going to affect things for us. So that negative, you cannot give the negative to both pieces. It either goes on top with the 3 or it goes on the bottom with the 2, one or the other. So that k value is negative 3 over 2 or 3 over negative 2, but not negative 3 over negative 2. And again, that's because the negative divided by the negative would make it a positive, which it is not. Okay, so same kind of thing. We're looking at our rise over our run. This time, since we have the negative on the 3, we are going to be going down 3 But my 2 is still positive, so that's going to be telling me to go right 2. Down 3 and right 2. Okay, starting at my origin. Boom. Down 3. So 1, 2, 3, and then right 2. And then I can just keep going. 1, 2, 3, right 2. Okay, and then to go backwards, we're just going to use the other k value. Instead of going down 3, we're going to go backwards and go up 3. 1, 2, 3. And instead of going right 2, we're going to go left 2. So again, you're assigning that negative either to the top or the bottom, but you're never doing them both negative at the same time. So again, 1, 2, 3, 1, 2. And you can go ahead and make your line after that. Okay. All right, you've got a bunch of practice problems to work on with that same process. Remember that if you're not getting a straight line, you're doing something wrong.